We're going into chapter 7, and we're going to learn how to solve oblique triangles. Oblique triangles are triangles that are not right. All the trig we've learned so far has helped us to solve right triangles. Well, if we don't have right triangles, there's trig that will help us solve that as well. And the first thing that we're going to learn in chapter 7 is the law of sines. So let's just draw, let's say, an acute oblique triangle here. It's really hard to draw an acute triangle that's not special to keep one of your angles from looking like a right angle. But anyway, if I label this triangle A, B, and C, and remember that we label the sides. Opposite side, or angle A rather, is side little a. Opposite angle C is side little c, and same way for side B, though I'm not going to label it right now, because now we know stuff for right triangles, okay? So I'm going to say I construct a perpendicular here from the base of this triangle ABC up to vertex B. And if I do that, of course, that would be the height of the triangle, and I'll call that point D. And since it's the height, we'll call that H. Now, if I was to do some trig, let's say that I want to find angle A in relationship with the stuff that I'm seeing here. Well, if I look at just the right triangle that I've formed with this perpendicular and look at triangle ABD, then I have the opposite of A, which is H, and I have the hypotenuse, which is C. Well, opposite and hypotenuse are sine. So I know for triangle ADB that the sine of A is equal to H over C, opposite over hypotenuse. Now, if I were to do the same thing over here for angle C, okay, looking at triangle CBD, then once again I have opposite and hypotenuse. So in that case, for that triangle, sine of angle C would be opposite, which is H, over hypotenuse, which is C. Now, if I do the old cross multiply, set things equal, remember sine of A would be over 1, so H times 1 would give me H equals C times sine of A. And if I do the same thing over here, H times 1 is H equals C times, oh, I'm sorry, that should not be C. I messed up. That right there, sine of C, opposite H over hypotenuse, which is little a, should be little a. So it is A times the sine of C. All right. So if both of these are H, then I can set them equal. That means I can say C times the sine of A has got to be equal to A times the sine of C. Now, if I divide both sides of this by sine A, sine C, and the reason I'll do that will be apparent here in just a moment. But we're going to divide by sine of A times sine of C. And I can divide both sides of an equation and not change the value of the equation. Sine of A times sine of C. Sine of A cancels here, and I get C over the sine of C. Sine of C cancels here, and I get A over sine of A. Folks, this is part of the law of sines. This is how we can use the information that we have in certain cases to solve oblique triangles. We'll look at it in a little more detail and give you some examples.